Hi, welcome to Mindset Learn Extra. I'm Katleho and today we're with Natasha. We'll be doing functions. Natasha, what will we be doing today?
Guys, we have been continuing with functions for a while now. We've done it for the last 2 weeks, and we're just going to really build on what you already know. We're going to specifically look at graph interpretation and also finding the equations of functions. And Katleho, I see that I have posted the challenge, or you have posted the challenge question. And people have already started answering.
Yes, you guys are fantastic. Yes, please continue to ask questions if you don't understand it. Remember, our Facebook page is facebook.com/learnextra and our Twitter handle is @learnextra. You guys know this already, so I don't even need to take you through it. Natasha, you're very happy with the answers, I see. And guys, after the break, we'll be going through functions again. And remember, guys, our show is brought to you by Liberty. You guys rock. Thank you very much. Natasha, should we go to a break?
I think that's a good idea.
See you after the break. Welcome back to Mindset Learn Extra Live. Today we're going through functions as you guys know, and we're giving away a Casio calculator to the lucky grade 10 with the best question posted or the best comment posted on Facebook. Remember guys, help each other out, be there for each other, answer the questions, go through everything, and we will be on Facebook just with you guys. Natasha, please, over to you.
Guys, thank you so much for answering our challenge question already on the Facebook page. I'm very, very impressed. Some of you are right on point and you've already got the right answer. Some of you are a little bit way off, so keep going at it. And I'm glad to see that all of you are awake, even though it's a long weekend. You haven't taken the weekend off, and you're busy working at your maths. Good to see. So as I said before the break, we're going to carry on with functions. We have been doing it for the last few weeks, and functions is really a massive section in maths. So, we obviously do it in lots and lots of detail. What I'm going to do firstly, before we actually start with graph interpretation and finding the equation, which is what I find most learners actually struggle with, I'm going to first look at just revising all the functions you've done so far. So if you for some reason didn't join us over the last 2 weeks, I'm going to quickly take you over the general functions, and we're going to revise all of the basic principles that you need to remember about each of these graphs. All right, so let's get started with that. The first one we're going to look at is the linear function, or the straight line. And the defining equation for the straight line you will see is y is equal to mx plus c. The m represents the gradient, okay, that tells you the slope of the line, and the c is the y-intercept. All right, so m is the gradient, c is the y-intercept, where it cuts the y-axis, and there's two different cases you can get here. If your gradient is greater than naught, so if your gradient is positive, you have a straight line that slopes towards the positive numbers. Now, if you think about your axis, you've got your x and your y axis, and if you've got a straight line sloping towards the positive axis, that means it's got a positive gradient. Okay. If you have the gradient, so if m is negative, then you have a graph that slopes towards the negative numbers. So if m is negative, you get a shape where the graph, as I said before, easy to remember, slopes towards the negative numbers. All right, straight lines, you actually do them in so much detail. You will do them when you look at coordinates or analytical geometry as well. So, you're going to really do this in a lot of detail. So make sure you understand, it really is a basic concept, but make sure you understand how to find your gradient, how to find your y-intercept, and how the gradient affects each of the lines. All right, but one of the big ones that I'm going to look at in a little bit more detail when we look at the revision of this is the parabola or the quadratic function. Okay, now guys, initially when you taught parabolas, you just taught y is equal to ax squared, and there's no q at the end. That's where it all starts, okay? And we then look at the value of a and we say, well, if a is greater than naught, you have a happy graph or a smiley face. All right, and you have a minimum turning point. If a is less than naught, we have a frown or a sad face. And there we have a maximum turning point. Okay, so that's really the basics that you learn about parabolas. However, when we add the q in, there's a few things to just remember. So I'm going to quickly go over what happens if we have a q and we add this into the parabola. Okay, so we're looking at y is equal to ax squared plus q, and we're looking at how q affects your graph. Now, originally, the graph that you are taught from in the positive case is y is equal to x squared, and there you have a graph that looks as follows. All right, let me just move that along so it looks a little bit more correct. There we go. All right, finally got that to work. All right, so the graph that you initially taught is y is equal to x squared. With that graph, what you'll see is that your turning point is the point 0, 0. All right, another thing is your y-intercept is also 0. So that's the graph y is equal to x squared. So a is just positive 1, so you have your happy-faced graph, and we have a minimum turning point at 0, 0, and the y-intercept is 0. Now say we add something in, like y is equal to x squared plus 2, for example. Let's see what happens then. Okay, so I'm going to use the same axes. Hopefully you guys can all see this axis. And I'm just going to use a different color. So let's use a green there. So if I have y is now equal to x squared plus 2. So all I've done really is I've added a 2 to the original graph. What's going to then happen is your original graph is going to move 2 units up. So the entire graph moves up 2 units. And this is the type of shape you get. That point is now 0 and 2. Okay, so if we look at the graph in green, we have y is equal to x squared plus 2. The new turning point is now at 0 and 2. And the y-intercept is now 2. So whereas in y is equal to x squared, you had your minimum points at 0, in y is equal to x squared plus 2, your minimum points is now at 2. So you see that with the addition of this q, you find your turning point changing and your y-intercept. Important to remember. The shape of the graph still stays exactly the same way. Similarly, we can do this for y is equal to negative x squared. And I can show you there also with the addition of the q, your graph is going to move down or up by a certain amount, which is your number q. So say we have y is equal to minus x squared. That's going to be a graph that looks like this. Okay, and this is supposed to be at the point 0, 0. All right, so that's just y is equal to minus x squared. In that graph, your turning point is 0, 0. And your y-intercept is also 0. If, however, I change that equation and I add in a value of q, so now if I say it's y is equal to minus x squared minus 1, for example, what's going to happen? Very similar to the positive shape. So if we have y is equal to minus x squared minus 1, you're now going to have a graph that moves down 1 unit. So the minus 1 tells us it's going to be a vertical shift downwards by 1 unit. So your graph's going to move down. All right, I'm not drawing them very, very accurately, but your graph's going to move down 1 unit. Okay, so that point, the new turning point, will now be 0 and minus 1, and the new y-intercept will be minus 1. All right, so guys, we just quickly revised how the value of q will affect your parabola. All right, so it's important to remember the things like the A affecting the shape, the Q affecting the vertical movement of your graph. You will also have graphs that don't only turn away from the x-axis. You can have graphs that cut the x-axis, and in that case you need to find the y-intercepts, and remember you find y-intercepts by letting, sorry, you need to find your x-intercepts, and you find your x-intercepts by letting y equal to 0. All right. So that's really just a brief revision of parabolas. Remember, I'm going through the first section really quickly, just reminding you all the different types of graphs we look at and how each of them are affected by this addition of Q now. All right. The one thing that I'm not going to go over, and you do need to know, and it has been done in a previous section, is trigonometry graphs. That will also fall under functions, and we have discussed all of those graphs in a previous session. All right, so hopefully you've all been following that. The next one we're going to look at, so going back upwards, so we've done the parabola. Let's now look at the hyperbola. So your hyperbola, the defining equation is y is equal to a over x plus q. All right, important notes here, a is never naught, x is never naught. Otherwise, you'll just have a straight line, which is not the defining equation of a hyperbola. So a is never naught, x is never naught. What happens with this graph? Very similar to the parabola where we moved it by q units. We take the original graph y is equal to a over x, which is the hyperbola that's drawn there when a is negative, and then here when a is positive. We take those graphs and we move them upwards by q units. All right? The one important addition here, and the one important thing to remember with the hyperbola, is you now have the addition of this thing called an asymptote, which is equal to the value of q. So usually when you would draw your hyperbola, you would just have the graphs not touching the x and the y axes. Now with the addition of this plus q, we actually move the x-axis up q units so that q becomes your new asymptote. So what does that all mean? Let's have a look at this in more detail. All right. So here we're now looking at the graph y is equal to a over x plus q. Remember, there's two different shapes we can get, one when a is positive, one when a is negative. And we're just looking at how this value q is going to affect the graph. So if we take a graph of, say, doesn't really matter what the value of a is, but say y is equal to 2 over x, for example. Okay, that's just a straightforward hyperbola. All right, so if I had to draw that, I'm going to have it in the first quadrant. I'm going to have part of the graph there, and then another one in the third quadrant. And there you see that the x and the y axes are actually asymptotes to the graph. Now, remember asymptotes, it's the line that the graph never touches. So if you're wondering what happens with an asymptote, it's a line where the graph is not defined. All right, so that's the original graph, y is equal to 2 over x. If I add in a value of q, so let's just say y is equal to 2 over x plus 1. All right, so that's my q is now 1. What's going to happen is q with a value of 1 is going to become the new asymptote. So y is equal to 1 is the new asymptote. So what I will have is I will draw an asymptote, or it's the same thing as moving your x-axis up 1 unit. And your graph, your original graph, is now going to be asymptotic to that line y is equal to 2. So in other words, it's not going to touch the line y is equal to 2. So this is the new line in green, guys. The new line, or the new graph, 2 over x plus 1. And then the other line, the other graph, is going to move up 1 unit. Okay, so if you see what happens there, your graph moves up 1 unit and now cuts the x-axis, and this line y is equal to 1 is now the asymptote. All right, so the q effectively just pushes your entire graph upwards, in this case because q is 1. So important things to remember when you look at hyperbole. Remember that the value of a affects the positioning of the graph. If A is positive, you're going to have sections of the graph in the first and the third quadrant. If A is negative, there'd be a graph in the second and the fourth quadrant. And very important thing to remember here is that y is equal to q is now the asymptote. Okay, and what we're going to do quickly is just going to look briefly at the last type of graph that you will deal with, and just revise that before we actually start graph interpretation and finding equations. The last one we're going to look at is an exponential graph. Y is equal to a times b to the x plus q. B will never ever be naught. So this is your exponential graph. Two different things can happen. You can either get a decreasing graph or you can get an increasing graph. How that happens is that if b is greater than 1, so say it's a number 2.5, 2, 3, whatever the case may be, if b is greater than 1, you will have an increasing exponential graph. If, however, b is a fraction, so anywhere between 0 and 1, all right, and here we're assuming that x is positive, so we only are using the value of b to tell us if it's increasing or decreasing. If b is a fraction, you will get a decreasing graph. All right, the asymptote in this case is the value y is equal to q. So just like in the case of the hyperbola, our asymptote is y is equal to q, and the value of a will affect the graph, but it's not going to affect the shape of the graph. So that's important in this case. It's either going to be increasing or decreasing. A could flip the graph around and do all sorts of other things, but if it just stands as it is, A is not really going to affect what we're looking at the moment. All right, so guys, that was just really a very, very brief summary of what we look at when we do exponential, hyperbole, parabola, straight lines. That's really just the basics of what you're going to look at with functions. But I think this is a good time to take a break and let all of that sink in. So I'm going to hand over once again back to Katlego so that we can go to a break.
Guys, I hope you guys are focused and on the ball. Kashifa, you're right. Long weekend doesn't mean that we must forget about maths. And there's already questions coming through. Thank you, guys. Remember that we'll take them in the last 15 minutes of the show. And enjoy your break. See you now. Welcome back, guys. Hope you guys got refreshed and revitalized. Natasha will be going through some examples now, so stay tuned. Natasha, over to you.
Thanks, Katlego. And thanks, guys. I see that you have been busy on the Facebook page, which is excellent, given that it is a Monday in between a long weekend. So I'm glad that some of you are still working hard. All right. Now, some of you might have thought that the last little bit of work went really quickly, but remember that's because we're just revising. A lot of that stuff has already been covered over the last few weeks on the live show. So hopefully you've been following. If not, I hope that you can go over your work at home and catch up and get to where we are. But as I said, this is the last week that we're going to be looking at functions. So we need to go a little bit quickly, and I need to cover the main thing that everyone struggles with, which is finding the equation of graphs and graph interpretation. So if you are finding it a little bit fast for you, maybe you haven't done it at school yet, so you can wait until you catch up, and hopefully you can understand as I go through it. Otherwise, just go over your notes and revise them, and hopefully you'll be able to understand what's going on. All right, the first thing we're going to look at is we are given a parabola, and you are asked to find the equation of the parabola in the form y is equal to ax squared plus q. Okay, guys, before you even do anything, before you decide how you're going to work out q and how you're going to find a, the first thing you need to do is examine the graph. So you look at it and you see that the shape is a frown. Remember, if it's a sad face, then a is less than naught. Okay, so immediately we can see that the value of a has to be negative. All right, so that's important. We can see just by looking, a has to be negative. So when you find the value of a, and once you've started doing the whole question, and if you get a value of a that's positive, you know that you've made a mistake, because we can see from the shape that a has to be negative. Another thing we can see from the graph is that it's not at the point naught. It doesn't start at the point naught, which means that the value of q has to be greater than naught. The graph has actually shifted vertically. Okay, so you can see those two things just by looking. Q is not naught and A is negative. Okay, so those things we already know just by looking. So how do we do this? Well, it's going to be a section that comes up over and over again that we use to find equations of graphs, and that's simultaneous equations. If you look at the graph, they give you 2 points to help you to find the equation, and they'll always do this. They'll give you enough information to find the equation. Okay, and I know often pupils after an exam, they'll come back and say, oh, but we didn't have enough information, and believe me, there's always enough information, unless your examiner has made a mistake somewhere. There's always enough information. All right, so here we've got the point 0 and 1 given, so we've got the y-intercept given as the point 0 and 1, and we're going to use that to help us to find the value of q, and we see that they also give us the x-intercept with the value of -1 and 0. Okay, so they've given us 2 points on the graph, and all you need to find the equation is just those 2 points, so you do have enough information. Some of you might be ahead of the pack, and you can see immediately that the value of q is 1, because remember, q is your y-intercept. So some of you will be able to read it off the graph immediately and say, okay, well, q is equal to 1. But for those of us who are doing it a little bit slower and not quite sure, you've just started the section, let's show you in detail how you'll show that q has a value of 1. All right, so we've got the defining equation. We write it down. Y is equal to ax squared plus q. And we're going to substitute the point, the y-intercept, which is 0 and 1. So we're going to substitute 0 for x, y is equal to 1, and we're just going to solve this. All right. So, and we're also going to use, in order to find a, we're also going to use the point -1 and 0 to help us to solve for a. All right. So, but firstly, remember looking for the value of q. If I say y is equal to 1, I know that the x value that corresponds to that value of 1 is 0. So I'm going to substitute x with 0. And we're going to put q in there, and we just solve this. So we get a times 0 is just 0, so therefore q is equal to 1. All right, so we get that immediately just by substituting the point 0, 1 into the defining equation. We can see straight away that q has a value of 1. Now we need to find the value of a. So all you're going to do, and this is where the simultaneous part comes in, because we know the value of q, we got it quite easily, but now to find the value of a, we need to set up another equation, and we're going to do that by using the point -1 and 0, but at the same time, you need to put in the value of q that you have already worked out. So, we've got y is equal to ax squared, and the value of q is 1, so we put that in, and we're looking now for a. So we substitute this point into that equation. So I'm going to say y has a value of 0 times a, and x has a value of -1. Okay, remember to use brackets here so that we don't get confused with the signs. And so we'll get a times -1 squared will just give me a, because a times 1 is just going to give me a, and that's going to be +1. So therefore, a is equal to -1. All right, so what did we do? We just took the 1 over to the left-hand side, and we've got a is equal to -1. And now it should make sense to you, because remember at the beginning we said a has to be less than 0 because we had a graph that had a frown. So now we know, well, hey, I'm on the right track because a is negative. So that sort of seems right. And we've got that q is equal to 1, which is the same as the y-intercept. So therefore, your equation is y is equal to -x squared, because remember, a was -1, plus the value of q, which is just +1. All right, and that's the equation of that parabola. Okay, so hopefully all of you were able to follow that. Just to remind you a little bit, when you are given a question like this, the first thing you would do is examine the graph, and usually by looking at the graph, you'll be able to decipher a few things without even touching the question. We can immediately see from this question that A was negative, so that's one thing that we know that we need to work towards. And we could also read off the graph what the value of Q was. In this case, Q was 1, or the y-intercept was 1. All right. So hopefully all of you who've started doing parabola at school have got this far and you understand how to do this. Okay, and I'm going to quickly have a chat to Katlego and see if there's any questions on this graph before I move on to finding the equation of hyperbola.
No, there isn't any questions for now. Guys, please post in some questions. Remember that we will be answering them along the way, as well as at the last part of the show. I don't know. Dumela asked you to clarify more on what the difference between the parabola and the hyperbola was. And Kashifa actually helped her. So that was fantastic, Kashifa. Thank you for pulling through. I know that you're really focused on this. You can keep going on to the next example.
All right. Okay, great. So guys, just to answer that question and make sure that you did get the right help there, the first major difference is obviously the shape. The parabola, which we did just now, looks completely different to this, which is the hyperbola. Also, the defining equations are completely different. The defining equation for a parabola is y is equal to ax squared plus q. And also, remember, there's always the square. There's the quadratic element of a parabola. Whereas your hyperbola is just y is equal to a over x plus q. So a divided by x plus q. Okay, so some major differences there. Let's have a look at the next part that we're going to do today, which is finding the equation of hyperbola. We've already looked at parabolas. And what they do is they give you another sketch like they would normally do if they want you to find the equation from a graph. They'd have to obviously sketch it. And they say find the value of a and q for the hyperbola. Remember the defining equation for hyperbola? Y is equal to a over x plus q. The big thing here, and we can see that it's here, y is equal to q is the asymptote. Okay, so remember we can already see it there. We need to know what that value is. Okay, and by finding the equation using the standard form, which is y is equal to a over x plus q, by using that we're going to be able to work out the value of q. If you look closely at the graph, you'll see that they gave you 2 points. You've got the point -1 and 2, and you've got the x-intercept 1 and 0. First thing we do, just like we did with the parabola, we examine the sketch. And guys, if you look at this one, what you'll see is that the two curves lie in the, let's have a look here, they lie in the second and the fourth quadrant. If your curves lie in the second and the fourth quadrant, that means that A is negative. Whoopsie, there we go, less than 0. So A is negative, and that's why we have a graph that, well, the two curves are separated in a way that you have one in the second quadrant and then one in the fourth quadrant. So straight away, by looking at the graph, we can see that A is negative. All right, we can also see, by examining, that the graph has actually shifted vertically upwards. So let's have a look at what's happening there. Remember, your normal hyperbola will have the x and the y-axis as the asymptote, but what you'll see here is your graphs have actually shifted up and away. So therefore, they've moved up a certain number of units, with y is equal to q being your new asymptote. So we know that q is not 0. So two things we've discovered. A is negative and q is not 0, just by looking at what they've drawn for us. Okay, now let's get into the tricky part, which is actually using the information they gave us to help us find this equation. The 2 points that they've given you -1 and 2 as a point on the graph, and I think it was 1 and 0, but let's just go back and double check that. And we've got 1 and 0. All right, so this is where, once again, we will use simultaneous equations to help us. All right, the defining equation is y is equal to a over x plus q. And it's not immediately apparent what the value of q is, like it was with the other question we did. First thing we're going to do, we're going to substitute the point minus 1 and 2 into this equation. So I'm going to substitute y is 2, x is minus 1. All right, and all I've done is I've just substituted the point that they gave me for x and for y. So therefore I get 2 is equal to negative a plus q. All right, and I'm just going to work alongside here, and I'm going to do the same thing with the point 1 and 0. So substitute 1 in place of x, 0 in place of y, and I'll get 0 is equal to a over 1 plus q. So therefore I get a plus q is equal to 0. All right, guys, so what have we done so far? We've used the 2 points that they gave us. We've just taken them straight from the graph, and we've substituted into the defining equation of the hyperbola to help us get 2 equations which we can solve simultaneously. Okay, so the one equation gave us minus a plus q is equal to 2, and the other equation gave us a plus q is equal to 0. At this point, what I'm going to do is I'm going to call this equation 1, and I'm going to call this one equation 2. In fact, I'm going to rewrite equation 2 so that it looks like this. A is equal to minus q. So all I've done is I've taken it across, and instead let's call that, let's call that equation 2. So a is equal to minus q is equation 2, and equation 1 is minus a plus q is equal to 2. With simultaneous equations, remember you need to use either, there's various methods you can use, and one of them being elimination, the other one being substitution. So I'm going to use substitution because I think it's going to be the quickest way to do this one. For you, you might find it easier to work with elimination, then by all means, you can go ahead and do it with elimination. So we've got a is equal to minus q, equation 2, and I'm going to say substitute equation. And also the reason I'm choosing to do substitution is not necessarily because it's easier, but we seem to use it more often. And in certain equations, it seems almost impossible to use elimination, and it's so long and it's so cumbersome. So I like to get students into the habit of using substitution, but nothing wrong with using elimination here. All right, so substitute equation 2 into equation 1. Remember what that means is wherever you see an a, you're going to replace it with minus q. So this equation is now going to look like this. 2 is equal to minus, and in place of a, we're putting in minus q plus q. So therefore I'm going to get a minus times a minus will just give us a positive q, plus the q outside there will give us 2q. So 2q is equal to 2, therefore dividing both sides by 2, I get that q is equal to 1. Okay, so if 2 is equal to 2q, divide both sides by 2, and you'll get that the value of q is actually 1. Now that we have the value of q, we need to find the value of a. How do we do that? We take the value of q, and we substitute it back into one of the equations. So I'm going to use it here. We've got a is equal to minus q, and all I'm going to do is, because I know what q is, just substitute that point in, and I get that a is equal to minus 1. So we've got a is minus 1, q is equal to 1. Therefore, your equation is going to be y is equal to a, which is minus 1, over x plus q, which is 1. And if you now look at your graph, remember what you were given? We said initially a has to be negative. Did we get a negative answer for a? We did. We got that a is negative 1. We know that q isn't naught, and we saw from using our simultaneous equations that q had a value of 1. All right, so hopefully I haven't lost any of you there, and I hope that you all have managed to keep up with the pace. As I said, it's a massive, massive section, functions, and so we're trying to do as much as we can over the last few weeks, and this is probably going to be one of the last lessons on functions. But a very, very important section, so please, please, please practice. And if you have any questions, send them over to Katlego, who I'm going to cross to now for a break.
Guys, remember, all your questions are read, so please send through questions. I see you guys are a little bit quiet, so maybe you're confused. Send all your confused questions. No question is a silly question. We'll probably be able to get through them if you send them, and enjoy your break. Welcome back, Mindsetters. Ludwig, Pumlani, and Luyanda, you guys are doing fantastic. Thank you for answering the challenge question. Remember, guys, it's still up, so you can still ask questions. And remember, the Casio calculator that will be given to the person with the best post on Facebook. Natasha, please carry on.
Okay, Katlego, it's been great. I've been looking during the break at the page, and a lot of you have got the question right, so I'm really, really proud of you. Well done. And I think the first person was Ludwig, who got the question right, or the quickest answer. So well done, Ludwig. And for those of you who haven't got, quite got there, we're going to go over that question in detail. It really is one of the harder questions that you would get. So if you can do this, then well done. You're on your way to doing really well at functions. Okay, so the question I posed to you was, you had a sketch, and they said that in the sketch, the graphs of y is equal to minus x squared plus 4 and y is equal to x minus 2 were given. They then asked you 3 questions, but it was all sort of like in parts. The one was to find the coordinates of a, b, c, d, and then the second one to find the coordinates of e, and lastly the distance cd. So let's have a look at the graph and identify those points. Okay, so we've got y is equal to minus x squared plus 4, obviously the defining equation of a parabola. So that's going to be the one with the frown. Okay, remember the first thing you do when you're given these kind of questions is look at the graph, examine, see how much of information you can get out of it. We know that the value of a here is negative. We have a frowny graph, so therefore the maximum point is going to be the point where the graph's turning from. So here your maximum point is going to be 4. We don't know if we need that, but we'll just write it down anyway. The maximum point is 4. The y-intercept is also 4. Okay, it's quite easy to see it from that equation. And then we've got the graph y is equal to x minus 2, which is your straight line with a positive gradient. And most of you will be able to tell immediately that the y-intercept is minus 2. Okay, and we get that by saying x is equal to 0, but we'll do all of this in detail. We're just having a look at the graph and seeing what we can decipher immediately. All right, now let's have a look at the question. They want us to firstly find the coordinates of a, and then b, and then c, and then d. Okay, so really what they're looking for with a and b is your x-intercepts of the parabola, c is the y-intercept of the parabola, and d is the y-intercept of the straight line. And guys, that's important. If you can actually sort of say it out loud to yourself, if you look at the points A, B, and C, and D, they mustn't just be points. They must mean something to you. So if I look at A, I know that's the x-intercept. So immediately you're telling your brain how to work out the answer. Because remember, x-intercept, you let y equal 0. So we're going to take the parabola and let y equal 0 in order to find the x-intercept. Remember your equation. Y is equal to minus x squared plus 4. And here I'm going to find a and b together because they are both x-intercepts. So to find the x-intercept, we say let y equal to 0. So therefore we'll get minus x squared plus 4, which is our equation of the parabola, is equal to 0. Divide through by the minus, you'll get x squared, oopsie. Okay, let's try that again. We're going to get x squared minus 4 is equal to 0. And then we can factorize that. It's a difference of squares into x minus 2 times x plus 2. So therefore, we get that the x-intercepts are minus 2, x is equal to minus 2, or x is equal to 2. So if I write this out as a coordinate, and it's important if they ask you to find the coordinates of a point, you need to write it in coordinate form. So don't just say minus 2. You need to write what the y value is. You need to write the corresponding value. So if I write this out as coordinates, I've got minus 2 and 0 as the one x-intercept. And then the other x-intercept is 2 and 0. Now remember, we're looking for a and b. So if we go back up to the graph, we see that a is the negative x-intercept, b is the positive one. So therefore, my answer is a is minus 2 and 0, and b is 2 and 0. All right, let's quickly move on to the next one, which is C, which is the y-intercept. Remember, for the y-intercept, all you've got to do is to let x equal 0. So now we're looking for C. So in y is equal to minus x squared plus 4, all we're going to do is let x equal 0. So therefore, I'm going to get y is equal to 0 plus 4. So y is equal to 4. Therefore, the coordinates of C would be 0 and 4. Okay, so that's easy enough. The values of C that we just got by finding our y-intercept, the values of A and B we got by finding our x-intercepts. Okay, and then the last thing that they wanted in question 1 was the value of at point D. So again, remember, these are coordinates. We always want x and y values. D, we said, is the y-intercept of the straight line. Y is equal to x minus 2. So for D, we're now looking at the graph y is equal to x minus 2. And D was the y-intercept. So we say let x equal 0. And we get y is equal to 0 minus 2, which is just minus 2. Therefore, D will have the coordinates 0 and minus 2. All right, guys, so pretty easy, the first question. It's just using the knowledge that you already have about parabolas and straight lines and just manipulating things to find the x and the y intercepts and then answering the question, according to what they want. Okay, so really part 1 was just looking for x and y intercepts. Part 2 is a little bit more tricky. Here we're looking for the coordinates of E. Now, if you look at E on the graph, okay, E is the point of intersection between the parabola and the straight line. And hopefully all of you are now shouting out, how do you find points of intersection? Hopefully you're all shouting out, we use simultaneous equations. So if I want to find the point where the two graphs meet, I'm going to have to solve the two equations simultaneously, and that will give me the coordinates of E. Okay, remember, when the two graphs meet, the x and the y values are exactly the same. All right, so all we're going to do is we're going to take the two equations and solve them simultaneously to work out E. Okay, so for E, we are going to do simultaneous equations. And the two equations we are interested in, y is equal to minus x squared plus 4, and y is equal to x minus 2. All right? So all we're going to do is simply call the one equation equation 1, call the other one equation 2, and I'm going to say substitute equation 1 into equation 2. So therefore, if I replace y into the second equation with equation 1, I'm going to get minus x squared plus 4 is equal to x minus 2. Bring everything over to one side, and you're going to get x squared plus x minus 2 minus 4 is equal to 0. Okay, I brought everything over to the right-hand side. And therefore, I get x squared plus x minus 6 is equal to 0. And we're just going to factorize that. And we're going to get x plus 3 times x minus 2 is equal to 0. Obviously, it's important here to understand your factorizing quite well. So we get x is equal to minus 3, or x is equal to 2. Now, does this make sense to everyone? Because we now have two answers, but we were only asked to find 1 point. And if you want it to make sense, you go back to the graph and look at the graph and see what you've got. You've got 2 points at which the graphs actually intersect. You've got the point E and the point B. So yes, it does make sense to have two answers because we've got the graph intersecting at 2 different points. The point B will just be the point 2 and 0, which we've worked out before. So obviously the point E has to be the other point. All right, so it's going to be the point x is equal to minus 3 and something. We need to find the y value, so we take the x value, put it into the second equation here. So we substitute it back in there. And I saw that Ludwig did get this answer, so well done. And you get minus 3 minus 2, which is minus 5. So therefore the point E is minus 3 and minus 5. So to all of you who got this answer, really, really well done. If you've got part 1 and part 2, good work. Okay, let's look at the last part very quickly. We are running out of time. Okay, the last one asked us to find the length of C to D. Now remember, guys, you've already worked out the coordinates of C. C was the point 0 and 4, and D was the point 0 and minus 2. But distances, which they're asking us for here, distances are never ever negative. So the distance from C to D can't be a negative answer, okay? We know that. That's a fact, okay? What we can do is we can divide it up and say, well, if that point is 0 and 4, the distance from C to the origin is just 4 units. And then the distance from the origin to the point D is 2 units. Therefore, that total distance CD must be 4 plus 2, which is just 6 units. Okay, so it's easy enough if we break it up. Or we could just say CD is going to be equal to 4, which was as the y coordinate at the point C, minus the y coordinate at the point D. So it's 4 minus minus 2, which would just give us 6 units. All right. Okay, guys, so we tried to cover quite a lot today, and I know it might be a bit much to take in, but it really is just a matter of practice. And I know I sound like a broken record. I say it over and over again, but really, maths is all about practice. And we've done quite a bit today. We've looked at finding equations of hyperbola, parabola. We've revised all the graphs, and we've looked at a very tricky example, which really, if you can do, then you will master the section. So well done to all of you who got this question right, and enjoy your holiday tomorrow. Back to Katlego.
Guys, we had a fantastic show. There was a lot that was gone through today. Guys, remember to practice. Use this challenge question as a stencil. Go through it a lot. Use it. And remember to ask questions. And, you know, people like Kashifa are always there and have your back. We had a fantastic show, guys. Thank you so much for all your questions and all your helping. You guys really were fantastic today. Tune in next week for another show. Thank you.